CMMS Radio talks about all things CMMS, computerized maintenance management software, focused on maintenance management. It's the people, the process, and the culture that make your CMMS journey a success.
All right, I get the honor of introducing Trent McJunkin. Trent. Trent is a manufacturing reliability leader. Trent started his career as a technician. He's held many roles in maintenance, engineering, operational leadership. He holds many credentials. I'm not even going to read them all, but definitely has continued his educational growth as well. His professional development includes technical certifications, condition monitoring, reflecting a strong commitment to continuous learning and practical applications. So he's recognized for bridging his technical expertise with leadership development, helping organizations strengthen both performance and people capabilities through disciplined, real-world experience. So thank you, Trent.
Thank you, Beth. Thank you all for being here today. Did anybody not have a delay getting to Reno? Some of the locals and some of the other ones. You guys timed that perfect. Any first-timers to Reliable Plant?
Oh, awesome.
Nice.
All right. So this is going to be exciting. Y'all are going to have a good week. So we're going to talk about the cycle of doom and the leader's responsibility. The cycle of doom is something that kind of came to me after being at the plant I was working at for about 21 hours straight, and all of the things that we should have done a year or more ago just started hitting all at one time. And I remember it being about 3 in the morning and us talking about how terrible it was, and then I just said, we're stuck. We're stuck in the cycle of doom. And then I started thinking about, how did we get here? So today we're going to talk about how I think most plants and most organizations can end up in this cycle, and then what you can do differently next week to break that cycle or start to improve it. So you have 7 stages here, and this is an article series that you can go look up on CMMS Radio or on LinkedIn if you're interested in going deeper. So it starts out with ambiguity, and then bad design decisions, hidden defects, then goes to firefighting. Firefighting leads to burnout, and then failed initiatives. You can't get traction with anything, and then it becomes institutionalized failure. That's just the way it is here. This is just a bad place. It's cursed. We're never going to be any better. So don't raise your hand if that's how you feel about your current operation. We've all at least worked somewhere before that we felt that way. So ambiguity is the lack of clarity about what good looks like. A lot of times teams are well-intentioned and they say, well, this vendor does this every day. They know what good is. We can just pawn it off to them. Your contractor or your integrator or whoever the specialist is incentivized by cost and speed, not your reliability, not your ability to run your facility for the lowest optimum cost. So if you don't have any technical specifications, you're putting it off on them to incentivize by cost and speed, because the one thing they have to do is win the bid. It's the only incentive they have, is to win the bid. Get the job, PO's closed out, and they're gone. If you don't define those reliability specs, such as alignment, materials to use, access points, they'll define them by cost and speed. That default assumption is that the right details will be handled by someone else. And these aren't bad people. Vendors aren't terrible people. It's just that they are incentivized by something different than what we are. So it's assumed that the vendor knows best, and they're a good resource, or industry standard. That's the most vague term in our industry, next to best practice. The way we've always done it. But explicit is an alignment tolerance. Current generation supported components, you don't want to open up an electrical panel and everything be something that you're going to have to go on eBay for. Material specifications, if you're running process piping, your piping has to be conducive to what fluid is going through it. I saw one job where we were pumping a lot of automotive fluids, and a cost improvement was to run galvanized pipe. So once you take a look at the inside of that galvanized pipe, it looks like mud. Torque specs, access clearance. If I have to get a 60-foot boom lift and grease a bearing, I'm not greasing that bearing. I'm just going to listen for it. Operating temperature. If it works great in a climate-controlled integrator, it might not work in the Texas heat. So where does it start? The reliability tax and these shortcuts and hidden defects. We've all been under a time crunch where we have to get things on time, under budget, and then we throw a party, we get pats on the back, everything's running, it looks good, but once you start to look close, it starts to look like that iceberg. Bearings are inaccessible, the components are obsolete, we have soft foot, bad alignment, there's no unions or flexible couplings on any of our process. All these things are baked in, and if we leave that in the scope as ambiguity, that gets rewarded. The shortcuts get rewarded. And they don't show up on day one. They show up 6 months later and they start to wonder, this is brand new equipment. Why is it falling apart? And new does not mean reliable. The hidden defect is a delayed consequence of an upstream decision. Everything seemed fine on the surface. Everything often runs well at startup. Low rate of production. If you're not stressing your equipment, you can't really see what it can handle. That's why these design specifications are so critical. Designing for RAMs, reliability, availability, maintainability, and safety. The project's on time, under budget. That was great. Everyone's happy. The asset's running, and we go to the next fire. But then that bill of ambiguity comes due, and you can't outrun it. Anybody here heard of the Swiss cheese model? Anybody here not heard of the Swiss cheese model? All right, half the room. This is going to change the way you think about everything, and this is probably going to make you a better communicator in your role. So James Reason is the guy who kind of came up with this Swiss cheese model. But if you've heard of a guy named Bob Latino is a great in our industry. And he taught me about the Swiss cheese model, and it blew my mind. And I said, this is what it is. This is how I can explain what I'm talking about in a way. So credit to Bob there. Each layer of defense is a piece of cheese. You can't get American. You gotta have Swiss. So the holes, each defense layer, or each piece of cheese, one day will line up. So we have to either eliminate pieces of cheese or make those holes smaller to reduce the probability of an adverse event happening. That could be a catastrophic failure, that could be somebody getting hurt, it could be a litany of other things. So when these conditions line up, something bad happens. Think about it like what we just talked about. I didn't have a rotating equipment standard. I didn't call out a specific lubrication standard, okay? Vendor optimized for what suited them. I don't have standard work. Operator does it this way on first, this way on second, this way on third. Operator makes a mistake. Procurement changed the type of lubrication that we used. All those things start to pile up, and now you have a negative event because we didn't have standards to begin with. So the root cause is ambiguity in the specifications, and also something called second order effects. Anybody heard of second order effects? So this is something that I got from economics. No original ideas here. It's just stuff that I've read about or listened to. So don't think I'm the expert. I'll tell you who the expert is. Learned about second order effects from a guy named Thomas Sowell. He's an economist, and he talks about how governments and people in public official capacities are incentivized for instant relief of an issue. Complaining about roads, complaining about taxes, boom, instant relief. Now you take that and put it into a factory or a manufacturing facility or oil and gas, how are your leaders incentivized? Quarterly, yearly? They're not going to be around for something that's going to help us in 5 years, help us in 10 years. They have to find that balance that gets us immediate relief now, but also invest in the future. So second order effect is something that was an unintended consequence. We saved money by going to a cheaper lubricant. Second order effect would be degraded reliability in our equipment. So the biology of burnout, when you have all these things starting to pile up, you have this reactive environment. Cortisol goes through the roof. Self-preservation mode. People aren't going to care about this initiative. People are going to incentivize what gets me out of here with the least effort possible because nothing's going to change. It inhibits oxytocin, which is the feel-good chemical in our brain. When survival is the goal, people cannot care about the company. I was doing a turnaround in Georgia about 8 years ago, and the plant manager couldn't understand why, despite all of his motivational speeches, nobody really cared. Nobody would get on board. Half the restrooms were shut down because of neglect. The parking lot looked like trash. They didn't have up-to-par PPE. Everything was just a big dump. It was awful. Nobody would want to work there. So I told him, I said, well, we're going to do some things that seem a little crazy, but we're going to show these people that we care for them and that we're here for them and start rewarding things that make their jobs easier today so that they can start to believe and care about what makes the company money in the future. Because people aren't going to do anything for you until they realize, hey, he cares about me, he wants me to have an easier job, cares about my future. That's in that circle of safety where trust and cooperation and people start talking about problem solving. Because the people doing the work, the people in the field, they care about problem solving until you show them that you don't care about their opinions. So they brought it up, they put in a work order, nothing happened, and then they stopped talking about it because this is the way things are here. We're in that institutionalized failure. So burnout is, a lot of times, it's not laziness, but it's a physiological response to an unsafe environment. And it drains more margin, talent, and trust than any technical failure. But we can trace burnout back to poor systems. So high cortisol, we talked about that, driven by fear and constant emergencies. I've worked in a few factories like that. You ever pull up to the job site, pull up to the manufacturing plant and just sit in your truck and dread going inside for 10, 15 minutes? You know, it takes me 3.5 minutes to get to the time clock, and I'm not leaving until 3.5 minutes until I have to be there. That's a big sign of burnout. It's not a character flaw. It's the natural consequence of an unstable system. People focus on themselves when they start to feel that self-preservation need. And then we've all seen the flavor of the month. We've all done something. TPM, 5S, lean, machinery, lubrication excellence, whatever you want to call it. We've done something and it didn't stick. A lot of times that's because we didn't do the pre-work early enough. We didn't have these technical delivery specifications. We didn't work with our vendors well enough. We didn't create belief inside the organization. So when people are trying to survive every day, every shift, initiative fatigue is going to set in. Here we go again. I've heard this before. Things are going to be different. They're probably not. They're just going to wait, and they're going to wait you out. This won't stick. Nothing ever sticks. This is the way things are here. So the moment that the chaos becomes the identity, that machine always fails. That becomes a fact of life. And people stop trying to solve those problems because, one, they never get any better. Nobody listens. Kind of doom and gloom. So moving from management to more stewardship, a lot of pressure from your ownership or your executives to meet quotas, hit KPIs, that short-sighted leadership. Hey, we got to hit our numbers this shift, this month, this quarter, or I'm going to lose my job. But when you start to add clarity and support and standards, and a lot of this is storytelling, why does this short-term initiative, this short-sighted project or implementation, cost savings, why does this actually hurt us in the long run? You as maintenance and reliability leaders actually have the advantage here, because oftentimes you can see the whole picture better than anyone. So you can inspire a team out of burnout. You can't buy them enough donuts or pizzas to get them to care more. You must, layer by layer, reduce those Swiss cheese layers and stabilize them out of it. We've all probably been in a role, or we know someone where the hero swoops in and saves the day. And I've been that technician where I love to go on a breakdown. They've been down for hours, put my cape on, swoop in, save the day. It's great, but you find something on a PM or a work order that could have caused 12 hours of downtime, but you fixed it and nobody says anything. So we incentivize the wrong things. But we must shift from that dopamine-driven heroics to a serotonin-driven culture of trust. W. Edwards Deming, if you haven't really read a lot of his stuff, I'd encourage you to check him out. Eliminate slogans, exhortations, and targets for the workforce. The bulk of the causes of low quality belong to the system. And the system starts much further upstream than the worker. So whenever you're in this chaos and every day is survival, it's similar to trying to teach a drowning man how to swim while he's in the water. If Matt doesn't know how to swim, anybody not know how to swim? I don't know how to swim. So Mark doesn't know how to swim. Mark, what would it be like if you're drowning? And I said, Mark, kick your legs. No, I need to get Mark out of the water, and then we need to talk about it. So trying to implement this initiative without trying to pull people out of the water first and give them a life raft, something to put their feet on and calm down for a minute, is probably going to fail. So chaos becomes the identity. We start accepting where we are as dysfunction is normal around here. So we drop our production target, machine availability, whatever you think it is, it's probably right. You know, good, bad, or indifferent. There is no plan. We sit in a planning meeting and everybody knows this is going out the window as soon as we walk out of this room. That machine always breaks. Nobody believes in the schedule. It's kind of just if you can hit it, great. If not, that's probably what's going to happen. The organization adapts to the dysfunction rather than fixing it. If you've been trying to plan shutdowns that don't happen well, or you constantly get your preventive capacity for your assets taken away, maybe you're in this stage. But none of these places chose to be dysfunctional. Nobody chose chaos. It was a layered decision process that got them there. We've all heard this before. Just do what you can. It's the white flag saying that there's nothing really we can do here. Just do your best. And we'll just keep on surviving until we get a new job or until they fire the plant manager. And then the new guy comes in with new ideas and inherits a bad system. So if we have unclear scope on the work order and no defined technical standards, design shortcuts are accepted at commissioning, and vendor decisions go unchallenged because they're the expert, your financial indicators can be that rework or maintenance overtime is going higher. Cost overruns on capital projects. Most companies think that all capital projects are going to go over budget, but they never look at the upstream indicators of why that happens. And most of the time, if you're always over budget on a capital project, it's because you did not anticipate properly some of the technical challenges that you were going to run into. Defects accumulating, technicians working around problems, same assets are failing repeatedly, so your overtime starts to trend up. Emergency PO spend increasing. You're going to pay for spare parts, or you're going to pay for overnight shipping. You get to choose which one you want. Capacity is consumed. We're not going to run a weekend shift. You're going to get that for maintenance, and then by Thursday, they're running all weekend. We've all been on there. You don't need a consultant to diagnose it. Walk the floor, talk to your people. They'll tell you what's going on. And then if you take off your blinders and you put some financial dollars behind it in a way that you can communicate the business objectives to your stakeholders, that's where they're going to start to listen to you. So there's ambiguous scope, rework, and warranty cost. If you catch it too late, your vendor's going to say, all right, issue me a change order. I'll put in some different material. We'll spec out a different pump, different motor. Design shortcuts. Once it's designed, that's your reliability tax. It's pretty much over. Your operational capacity is baked in once that design is complete. Hidden defects. If you're not requiring some very rigorous inspections during commissioning from your team, the owners of the equipment, you are asking for all kinds of trouble. Firefighting culture. Overtime gets inflated. Your capacity to do PMs and maintain this equipment gets consumed by what our leaders are incentivized by: volume, hitting their targets. Capital gets destroyed. Morale gets depleted once all these failed initiatives start piling up. They die quietly. You see this dusty old sign on the wall of that time we did lean manufacturing, or when we tried TPM, or all these brooms that we bought for 5S, because everybody knows 5S is buy brooms and dustpans. Normalized instability. That starts to erode your margins, and it's invisible until it's too late and it starts showing up on your financial reports, and then the waters are so muddy that you can't explain it. And then you start getting in this really vicious cycle of, well, if you knew that, why didn't you say something? Same reason the operator and the tech didn't say anything either. Nobody listens. So how do you stop it? First step is kill ambiguity. If you don't have some sort of rotating equipment standard or acceptable vibration standard on your equipment, you are asking for chaos inside your assets. If you don't specify what type of lubricant, what type of lubrication points, what kind of access do you need, all those things, if you're not giving the vendor this, here you go, I'm going to check you on the back end, but I need you to go ahead and plan for this, you're setting yourself up for a big fight. Bring maintenance into the design. They may not be able to help you put it in RFQ technical language, but they can tell you, hey, that chiller that you guys bought does this, this, and this. Or this asset, I always have to do this. And if you can read through that language, add it in. Specify the unsexy. I had an engineer design a piece of equipment where I walked up, he said, hey, they just finished up. We gave him the green light, we're gonna close out this PO, and I walk up for the first time at this site, and I see my motors are mounted on unistrut on the concrete floor. And I said, what's that? I said, oh, those are motors. I said, dumb question, dumb question. So it also had galvanized pipe. I didn't have any unions in any of my pumps. If I can't think of anything that went well. So we got to pay about 50% more to go back and redo it on the next shutdown, because that company at the time did not have a technical delivery specification. Stabilize first. So we've all got some zombie initiatives that are still running. There's still some hope. Maybe we're going to get on board with this thing, but we all know that's not true. Go ahead and kill one. That is creating your constraint. And that constraint is what's hindering your throughput to get you that maintenance capacity back so you can get back to your assets and get them back to the designed capability. One thing that we do, if it's real, can beat 10 programs that we're trying to believe are still alive. Rebuild belief. You've got to call the elephant out in the room. ADCAR is great. John Cotter, his model is great. Pick one and do it. They're both good. Name the cycle of doom, admit that this system's broken. If you're just one of the talking heads that says it's going to get better, this next asset we put in is going to be flawless. Call it what it is. Create that desire. Fix one nuisance problem to prove that change is possible. This may not be, and probably will not be, something that impacts the bottom line, but it impacts how wore out your technicians are going home. It impacts their cognitive load that they carry in your plant every day. Teach how to fix the specific irritant. Talk about how did it become this big monster? Was it an unspecified material or unspecified technical requirement? And give them the time and the resources, the margins to do good work. It's hard to go through the trouble of writing a standard and tell them, hurry up every chance you get. We got to get this back over to production. And celebrate the win. Even if it's small, act like it's the Super Bowl. So those will always compound. Most initiatives fail at ability or reinforcement. Either we don't have time or we don't change the culture. We just think we're going to go hire this consultant, or I'm going to go to this conference and I'm going to get this new program and I'm going to roll it out and it's going to fix all of my problems. I'm going to buy this software. It's going to fix all of my problems. If you don't actively work to fix the culture that your company has created, everything is going to be a waste. You're going to come hang out and have a good time, meet some cool people, but you're not going to get any better. Let's find the loop. What is escaping? What's the thing that's happened most frequently? Eliminate the root cause. Focus RCA with the people who actually touch the asset. You don't need every single department in the plant. Just the people who are working with it every day to triage what you have going on. Protect the freed capacity. Once we get some of that capacity, we have to protect it, or it's going to get consumed back by production. Restore control upstream. Everything, every asset, every standard, every scope, every document has a named owner. If we all own it, it's going off the rails. If everybody owns it, nobody owns it. One person is accountable for each critical system. It's documented. When something fails, there's no ambiguity about who answers it. I thought quality owned it. I thought maintenance owned it. I thought engineering had that. Never going to work. Non-negotiable technical minimums are written, trained, and enforced. It's not enough to define your electrical motor, pump, any kind of rotating equipment standard and give it to the vendor. You have to go back and educate your team on why it's important. And then when the vendor installs it, go back and check. Did they follow this? It has to be documented.
In some cases, you've got to go back to the vendor and teach the vendor because they don't get the standards.
Right. You would be surprised, maybe not, but you may be surprised at how many vendors don't know the right way to do these things. And if you're the customer that shows them how to do it and doesn't beat them over the head for not knowing their stuff, they're going to love working with you. That's going to become a vendor partner. If you look at companies like Toyota, they regularly send their in-house team to their suppliers and to their vendors to show them the right way to do things to make the pie bigger for everybody. So don't cut out all your vendors who don't know these standards. You may run out of vendors.
The other good thing you do there too, what I found out was that if you train your vendors how to do something better, then that gives them added value over their competition.
Yeah.
To sell that to other companies to help improve other people or other companies what they're doing and stuff. That became pretty valuable 35 years ago at a facility that I worked with.
Oh yeah, and once you start putting money in that relational piggy bank with your vendors, you start investing in them, show them, hey, here's why we want this done this particular way. They're gonna love working for you. They're gonna love quoting your work. They're gonna get a better reputation. They're gonna get better talent. And they're probably gonna start winning more of your bids because they're more aligned with your expectations. So what is the role of the leader? We've got to move from being the fire chief to the architect of the system, rewarding the heroics, addicted to the chaos, the activity, and this dramatic environment. Everybody knows you walk into a lot of organizations that we work for or have worked for, it is chaos from the time you get out of the truck until the time you go home. And then the phone is ringing until you decide to put it on silent. But rewarding prevention, and it's tough to get out of that mindset of celebrate the hero, but also celebrate the guy who found this critical defect and prevented it, and tell that story, and help reward that, and incentivize that, and establish urgency around clarity. If you do the work early, if you do the work so far upstream that you feel like I'm getting too lost in the details, we'll figure it out on the back end, you're never gonna do it. You're about to get hosed, and you're about to be so covered up with all this chaos that you let slip on downstream that you're never gonna get ahead. And the best maintenance and reliability role is a boring one, a very quiet and very predictable environment. And if you have not reached that point in your career that you want a boring reliability job, it's pretty sweet. A well-managed plant is a quiet place. A factory that is dramatic is poorly managed. It comes from Peter Drucker. Start rewarding the fire marshal, the person who prevents the fire. Don't just reward the firefighter. The leader's role is to protect the system so that people can protect the plant. Move from command and control to clarity and support. When the system breathes and the system has some capacity and some flexibility, the people can too. The people can do better work when they're not just getting beat every day by all of these variables. So if you do 5 things Monday when you go back, spend 1 hour mapping where ambiguity is in your process. Go to Gemba if you've heard that. Define one standard, and I'm sure if you're here, you have at least one, you're like, oh, we need that one standard. Define that, define what good looks like. Don't say best practice, don't say industry standard. Add that as supporting documents, but call it out specifically. Kill a zombie, one thing that has been dead for 6 months and everybody knows it. Call it what it is, kill it. Add that capacity back to your team. Inspect one asset with a floor walk. Was it installed with clarity or vendor assumptions? And then mark out what happened and why. You're building your technical delivery specification when you do this. And remove one source of pressure to create margin. Remove one barrier. So a lot of this is not super technical. It's involving the right people and having those conversations, and then being able to spin that into a story that your leadership team can understand. Understand the business objectives and speak in their language in a way that benefits the maintenance and reliability of your assets. The ambiguous scope that started the cycle, a leader approved it. Somebody. It may have been us unintentionally, us really stressed about all the projects. And we said, yeah, it's fine. The design shortcut that installed that reliability tax, there's a leader in your organization that signed off on it. The standard that was never enforced at commissioning, a leader allowed that to happen. The improvement initiative that stalled, a leader didn't protect the time for it somewhere. So I'm not anti-leadership, but I want to really harp on the fact that leadership is in control of this. And if you're in this room, if your company is thinking enough of you to send you to a conference, you're viewed as a leader. You have a say, you have ability to tell that story. It's a leadership problem. The cycle of doom is a leadership problem that often wears a maintenance uniform. So speak up for your assets, speak up for your people, so you can begin to protect the margin of your company. Leaders who understand this stop asking, why does maintenance keep failing, and start asking, what did I allow upstream that made this inevitable? Look at the Swiss cheese model, look at your second order effects. You're dealing with a lagging KPI. You're dealing with something that happens so far downstream, you have to go upstream to find where it started. Define what good looks like. Set written, measurable standards for critical assets and critical work. If it's not written, it doesn't exist. Protect your preventive capacity. Once you get that capacity back, you have to keep it. Enforce scope discipline. Once you have good scope, you have to maintain that discipline. Unambiguous work scope can't happen. Ambiguity is a cost you are choosing to pay later. Kill the zombie initiatives and make the win visible. I can't express that enough. Fix one thing that makes somebody's day better and make it a big deal. So the technician who works 16 hours to fix the emergency versus ask why the emergency happened and who owns the prevention. Not for blame, but to identify the root causes, because there's going to be more than one. There's going to be layered root causes. Launches a new reliability program when the last one stalled versus ask what killed the last program before starting the new one. Why couldn't we do lean manufacturing? Why didn't 5S get off the ground? Why didn't TPM make an impact? You hear a lot of, we're doing the best we can. Or ask what would need to be true for us to do better. What is hindering you from doing the best job possible? And you might get some hot takes on that one, but just take it with a grain of salt and then address them. All right. I may not have all the answers, but I think we have some answers in the room if you have some questions.
Real quick, Trent,
Yes.
I'm curious if any of these materials can be made available for people to review, like the deck or anything like that?
Yeah, by the end of the conference, this will be on the app. So you'll be able to download everything by the end of the conference.
Thank you.
Mark?
One of the things you've been talking about, was the design issue of it. 38 years ago when I started my reliability career, we had standards for gear tooth contacts, your sleeve bearing fits, vibration standards based on gear mesh frequency, vibration frequencies. We had standards for soft foot. We had requirements for design around resonant frequencies and stuff like that. And you just don't see any of that coming from anybody anymore. And when you ask people if they're even doing a running inspection before a critical asset, motor, gearbox, whatever, leaves their vendor, people aren't doing it. They're just like you say, it's like they know what they're doing. They'll give us what we paid for. And they don't. I had an argument 20 years ago with Falk on a gearbox that we had a problem with, and Falk came in and they were upset because it was a $180,000 investment, but the vibration levels were getting high, and Falk came back to me and said, those vibration levels are well within our standard. So I had data on a gearbox that they had rebuilt for that facility 5 years prior, showed them the vibration levels that were there, showed them the current vibration levels that we had, and told them that this is the one you rebuilt, this is the one that's running that I'm saying has a problem. The levels are higher on this one, and they still haven't tripped your alarm. You know what happened the last time. Are you willing to step up and give these guys warranty claim on this one if they continue to run it? The thing was pulled out 2 months later. Because they just did. And what I found is that you got to get comfortable with having the uncomfortable discussions with some of these people in the beginning to get the stuff turned around.
Definitely. And a lot of commissioning, I see that it's really limited by percentage of uptime or units per hour over a span. But we have stopped at some point by measuring the output where we used to, at some point, measure the inputs. How good are your inputs, and that will determine with a higher level of certainty your outputs. At some point we crossed that bridge, and I'm not sure where that happened. Any other questions for anybody? All right. Thank y'all.
Let's hear it for Trent. Come on. Well done, brother.
Appreciate it.
Pilot on your CMMS project, visit cmmsradio.com and use the What's on Your Mind link. Thank you for tuning in to CMMS Radio, your resource for all things CMMS, from selection to implementation, to help you make better choices, learn from industry experts, and have a successful CMMS journey.